Hey guys, welcome back. In this video, we're going to take a look at factoring. So a quick introduction to what factoring is, and then how to factor using something called greatest common factors. All right, so we're looking at factoring using greatest common factors. So when we talk about something called a product is just the result of multiplying two things. So something times something gives us what we call a product. These things that we're multiplying are called the factors of that product. So when we talk about factors, we're talking about the things that we multiplied in order to end up with that number. For example, if we had 6, two factors of 6 are 2 and 3. So 2 and 3 are factors of 6. 1 and 6 are also factors of 6. So two values that when we multiply them give us the product at the end. So that's what we mean when we talk about factors. Okay, so when we factor a number, what we're doing is we are rewriting it as the two factors being multiplied. So when we want to factor 6, we rewrite it as 2 times 3. So if we're asked to find factors of a number, for example, if we're being asked to find factors of 8, well, we have 2 and 4. We also have 8 and 1. Some other factors you could also include are -2 and -4 and -8 and -1, because negative times a negative gives us a positive. Okay, so we're rewriting 8 as numbers being multiplied. So that's what it means when we factor a number. Sometimes we'll be asked to factor more than one term. So here 8 is just one term, but sometimes we'll be asked to factor a binomial or a trinomial. So for example, if we're being asked to factor 2x plus 10, we're trying to rewrite this entire polynomial as two factors being multiplied. What we have to do here is first find the factors of both, or factors of all terms individually. Secondly, we're going to identify any common factors. Identify any common factors. So factors that are shared by all terms. And thirdly, we're going to factor out, which will show what that means in a moment, these common factors. Let's take a look at our example above. We have 2x plus 10. What we're going to do first is find the factors of all terms. So 2x can be written as 2 times x. 10 can be written as 5 times 2. 10 could also be written as 10 times 1. Usually we don't worry about rewriting it with the 1 though, so we're just going to do 5 times 2 for now. Okay, so we found factors of both. What we can do is rewrite these terms actually as these factors. And then we're identifying any common factors. So notice that for the 2x, we have a factor of 2. For the 10, we also have a factor of 2. So 2 is a common factor. So what this means is finally, number 3, we're going to factor out the 2. So we take our 2. And when we talk about factoring out, what we're doing is kind of like the opposite of distributing. So instead of distributing a number to both terms, we're going to be taking a number from both terms, the same number, and then taking it out of both of these. So we're taking our 2, and kind of like the opposite of distributing, we're pulling it out of both of our numbers. So we have a 2 in front, and then in parentheses, we write down whatever we have left. So 2 times x plus 5. So 2 times x plus 5. And this right here is the factored form of 2x plus 10. We found a common factor and we factored it out and then rewrote it as its factors. 2 and x plus 5 are two factors of 2x plus 10. So sometimes factors can be polynomials. As you can see, x plus 5 in this case is a factor. All right, let's take a look at another example. Here we're trying to factor 12x squared plus 18x. So we have a polynomial here, a binomial, and we're trying to rewrite this as its factors being multiplied. So again, what we're going to do is identify all of the factors. For 12x squared, we could rewrite this as 3 times 4 times x. And if we wanted to go further, when we talk about something called prime factorization, that means that we rewrite as prime factors. So we're going to keep factoring until all of the factors we have are prime. So x we would consider prime. We can't really split that up anymore. 3 is a prime number. 4 is not a prime number, though. So we could actually rewrite this as 3 times 2 times 2 times x times x. So that's 12x squared. For 18x, we could rewrite this as 6 times 3 times x. And again, 3 is prime, but 6 is not. So we could rewrite 6 as 2 times 3 times 3 times x. So for prime factorization, we're just rewriting it as splitting it up as much as possible until we get prime factors. Okay, so one way to approach this is to look for common factors. Let's take a look at, instead of looking at the prime factorization, let's look at the first factorization that we did. So 3 times 4 times x, and then 6 times 3 times x. So here, if we look for common factors, we see that 3 is a common factor for both of these. So 3 is a factor of both of these terms. So what we can do is rewrite these terms as 12x squared. 12x squared is going to be rewritten as 3 times 4 times x. And then 18x, we're going to write, I'm just going to move the 3 in front, 3 times 6 times x. So here, following what we did in the last example, we can factor out our common factor, which is our 3. There we go. So we're moving the 3 outside. And then on the inside, we're leaving what's left over, which is 4 times x plus 6 times x. Okay, so we factored it out and we rewrote this as 3 times 4x squared plus 6x. So this is what it looks like when we take out one factor in this situation. However, we aren't completely done, because when we're asked to factor, what that means is that we need to completely factor. So we need to check the factors that we come up with and make sure we can't factor further. So we can't do more factoring. So 3 we know is prime, so we could leave that. 4x squared plus 6x, however, is not prime. In other words, we could rewrite this as more factors. So what we need to do is keep going. So if we started off by taking out the 3, we could look at 4x squared and 6x. 4x squared is 2 times x times x. 6x is 2 times 3 times x. In this case, let's identify all of the factors. 2 is a shared factor. X is also a shared factor, so variables can count as factors. So rewriting this, we have, just gonna write to the right over here. We have 4x squared plus 6x. 4x squared can be rewritten as 2 times x times 2 times x. 6x is 2 times x times 3. So again, just like we did before, we're taking our common factors, which is 2x, pulling it out in front, and then rewriting it as 2x times whatever is left over, 2x times 2x plus 3. So if we take this and finally put it back into our equation, we end up with 3 times 2x times 2x plus 3. So I'm replacing what we just factored. And then we could simplify, we could multiply these two, 6x on the outside and then 2x plus 3 on the inside. So this would be our final answer here, 6x times 2x plus 3. 2x and 3 don't share any factors, so we can't factor them any further. Okay, so in this example, we got to completely factoring it, but we had to do quite a few steps. So this is why it's important that we find the greatest common factor. Greatest common factor. In other words, when we find common factors at the beginning, we want to find all factors to start off. So find all of the factors that they share and then take all of those out. One way to do this is to split it up into prime factorization and then identify all of the numbers they share and pull those all out. Another way to do this is to look at the different ways we could rewrite the terms and then looking at all of the factors that we have for these terms, find any that they share. And then the highest number they share is what we're taking out. So a quick example, 12x squared plus 18x. Our same example here. 12x squared can be written as 6 times 2 times x times x. It can be written as 12 times 1 times x times x. It can also be written as 3 times 4 times x times x. So one way is to rewrite it, and all the different ways we can rewrite it. 18x is 6 times 3 times x. 18 times 1 times x. Or 2 times 9 times x. So here, what we're going to do is look at all of these different factors and find the greatest factor that they share. In this case, they both share 6 as a factor. They also share 2 and 3, but 6 is the greatest common factor. And then x is also a factor they share. They also share the variable x. So 6x is what we're going to be rewriting this as. Okay, so 6x times 2x, whatever we have left over, plus 6x times 3. And then now we go ahead, take out the common factors, and then we'll end up with that final answer we got on the previous slide up above, which is 6x times, in parentheses, 2x plus 3. Another way to do this is to write the prime factorization. So down here we have the prime factorization, and then find all of the prime factors they share. So they both share a 3, and they both share a 2, and they both share an x. So here you can find all of those, and then we're going to be taking all of those out, which is the same process as just finding 6 as the greatest common factor and taking out the x also. Okay, so that's what we mean when we talk about greatest common factors. And finding the greatest common factor is important because it actually saves us time, so we don't have to keep checking to make sure we factored it completely. Okay, let's do one more example, taking a look at using common factors to factor. Here we'll take a look at a little bit more of a complicated example. Let's do 12x to the third plus 36x squared plus 8x. Okay. So what we're going to do is first take a look at all of these terms. We have 3 terms now, so we need to find common factors between all 3 of them and find the greatest common factors. So 12x to the third we could write as 3 times 4 times x times x times x. So all of our terms are going to have the 3 x's. 3 times 4, we could rewrite this as 6 times 2, or 12 times 1. For 36x squared, we could rewrite this as 6 times 6 times x times x. And again, these are all going to have the x's. We could rewrite this as 3 times 12. Of course, we have 36 times 1. And then we could also rewrite this as 4 times 9 times x times x. For the 8x, we have 2 times 4 times x. We also have 8 times 1 times x. Okay, so taking a look at all of these, we want to find the greatest common factor. Probably the easiest one to start off with is the 8x. So here we have 2 times 4 and 8 and 1. They don't all share 8 as a factor. So going down, let's take a look at 4. So we can see 4 is a factor here. 4 is a factor for the 12x to the third. And 4 is a factor down here for the 36x squared. They also share an x. All of them share an x. Okay, so next what we'll do is rewrite all of our terms with those common factors. So let's start off with the 12x to the third. Here we have 4 times x. So I'm writing the common factors first. Times, and then whatever we have left over. So we have 3 times x squared, or x times x. Okay, next for the 36x squared, we have 4 times x. So I'm taking the 4 and the x out. And this is where the x would be if we copied them down. And then what we have left over is a 9 and an x times 9 times x. Finally, for the 8, we have 4 times x. And all we have left over is a 2 in this case. So times 2. Okay, finally, we are taking out that common factor 4x from all of them. So we're doing for all 3 of these. We're going to have the 4x in front. And then on the inside, we'll have 4x times, we're writing what's left over, 3x squared plus 9x plus 2. Okay, and these don't share any common factors, so until we learn more about factoring, this is called a quadratic. We're going to say this is factored for now, so we're going to say we're good to go. So we have the two factors, 4x and 3x squared plus 9x plus 2. So we factored our original polynomial. Okay, so I'm writing out every single step just to make it clear what we're doing and why it's important to do it in this way. For example, why it's important to find the greatest common factor. It's okay if you skip some of these steps or go a little bit more quickly through it. Just make sure that you're completely factoring it. And a good way to check your work too is to just take your factors and then re-multiply them. So take our 4x, distribute it, and see, do we end up with the original polynomial? And if so, then they are equal, in fact, equal. Okay, so that's how we can factor using greatest common factors.